Hi friends, this is Arshad Jagidar, working as one of the faculty in Department of Civil Engineering of CCAB Institute of Engineering and Technology. Today my topic is on one of the problem on equilibrium of forces. How to find the unknown forces in equilibrium of forces using Lami's theorem and using the equilibrium conditions. Now let us first understand what is the problem over here. Here there are two identical rollers, each of weight 200 newtons. Both the identical rollers are of 200 newtons. They are placed in a trough between two planes. One is an inclined plane with an angle of 30 degrees with respect to ground, and another plane is vertical plane. So between these two planes, these two identical rollers are placed, connected at different points or contact at different points at A, at B, at C and at D point. Here there are different contact points A, B, C and D. Here we need to get what are the reactions going to develop at these contact points at A, at B, at C and at D on these two identical rollers. So now let us first draw the first free body diagram. Before drawing the free body diagram of any of the rollers, let us first calculate the angles, and for that first show the reaction from the contact point A always towards the supporting point. Let us take that as RA. RA is the reaction from the contact point A towards the O2 identical rollers. Now similarly, if you look at, always this reaction is perpendicular to the plane of support. Here the angle is 90. So we are getting one triangle which is called as a right angle triangle, where one of the angle is 90 degree. So we can easily get this third angle unknown by deducting 90 minus 30, which gives 60. That 60 will be taken with respect to x-axis at the center point of this O2 point, because alternate angles are always equal. Similarly, you show another reaction from the contact point C towards O2, that is RC. Let us take RC is one of the reactive components or reaction from the contact point C towards the O1. Similarly, take another reaction from the contact point B, that is RB. So when you are showing the free body diagram of this, here the reaction will be towards the point. The reaction will be towards the point. When you draw the free body diagram of this, you have to show that as towards the supporting points. Now here also, if you look at one, we are getting a right angle triangle where one of the angle is 90 degree. This angle is also nothing but 60 degree. If this angle is 90, remaining angle from, if we deduct 30, 90 minus 30 gives 60 degree angle, and that 60 degree angle will be over here with respect to x-axis. What is the remaining angle when these two are perpendicular? This angle will be over 30, and again the alternate angle 30 is same. Alternate angles are always equal. Now first we need to draw the free body diagram of O2. So while drawing the free body diagram of O2, there are three forces acting on it. The first one is its own weight. So let us first draw the free body diagram of O2. O2 is the upper roller. So while drawing the free body diagram of this, first we need to draw the all four quadrants at O2. All four quadrants at O2. Now the first force applied at O2 is its own weight, and that own weight is always act like a downward force, that is of 200 newtons. And what is the second force applied on this O2? That is applied with RA. RA is the reaction coming from the contact point A towards this O2 point. And what is angle measured with respect to x-axis? Its angle is measured with respect to x-axis is 60 degree. Already we have calculated these alternate angles. So that same angle we can take it with respect to x-axis. And the third force coming on O2 from the contact point B is RB, and that is shown towards the supporting point like this. Show the reaction from the contact point B, that is RB, with an angle of 30 degree. So this diagram is called as free body diagram of the joint O2, or the center point of the upper roller. O2 is the center point over here. Now, how to get the reactions RA and RB? Using Lami's theorem. Let me tell you the statement of Lami's theorem. What Lami's theorem says here is, if three forces acting at a point are in equilibrium, then each force is directly proportional to the sine of angle between the other two forces. Now let me explain that statement by writing the mathematical expression. RA divided by sine of alpha is equal to RB divided by sine of beta is equal to 200 divided by sine of gamma. Here RA, RB and 200 are the three forces where the line of action of all these three forces meet at one common point, and their opposite angles are alpha, beta and gamma. Now let us measure these angles, alpha, beta and gamma. RA divided by sine of alpha. What is alpha here? Alpha is the opposite angle of RA between the other two forces, right from here to here. It is measured as 90 plus 30, which gives 120. So that you have to write it with sine is equal to RB. Now RB is unknown force divided by sine of beta. Now beta is the opposite angle of RB, which is measured between the other two forces. From the Lami's theorem, it says that each force is directly proportional to the sine of angle between the other two forces. So RB opposite angle is beta. How to measure the value of beta over here? 90 plus 60, which gives 150 degree. And that we have to take it with sine of trigonometric ratio sine. Next, 200. 200 is the third force acting at the same point, divided by sine of gamma. Here gamma is an opposite angle of 200 measured between RA and RB. How to measure it? Out of 180 you deduct these two angles, that gives gamma. Gamma is equal to 180 minus 30 plus 60. Deduct these two angles from 180, because one straight line angle is 180. Deduct 90 from 180, we will get remaining angle is 90. So that gamma is equal to how much here? After solving, that gives 90. So that also you have to use it with sine. Now to get the value of RA and RB, equating first ratio and third ratio, and equating second ratio and the third ratio. On solving, we will get the value of RA is equal to 173.20 approximately in newtons, and RB is equal to 100 newtons. These are the answers for the reaction from the contact points A and B on the roller O2. The third force is already known, which is the own weight of the O2. Now in a similar way, you have to draw the free body diagram of the lower roller, that is the free body diagram of O1, showing all the number of forces acting on it. Now let us draw the free body diagram of O1. While drawing the free body diagram of O1, first we need to start with all four quadrants at O1. This is O1 point. Now the first force acting on O1 is its own weight. always own weight of any body is act like a downward force. Take that force towards down with a magnitude of 200. Both the rollers are of same weight, acting like a downward forces. So 200 Newton is the own weight of the lower roller or identical roller. Now the second force is a reaction coming from the contact point D. That is taken as RD. Show that reaction as RD. And always whenever the reaction is showing from the contact point, that will be always perpendicular to the plane of support. And the next reaction coming from the contact point B is RB. That RB already we got it from the earlier calculation, that is 100 newtons. While showing the free body diagram of O1, the reaction from the contact point B is shown towards the point with an angle of, what is the angle over here? The angle over here is 30 degree. And what is the third force coming on, the fourth force coming on O1? It is from the contact point C, and that is coming towards the O1 point. That is RC. What is its angle known? Its angle is known as 60 degree. All the angles are always equal with respect to axis. When this angle is 60, the same angle is taken at the other end, at the other end of the plane, where the reaction is always perpendicular to the plane of support. Okay. Now here, if you look at clearly, there are four forces acting on O1. I will explain one by one. First is its own weight. Second, the reaction from the contact point D. Third is the reaction coming from the contact point B towards this point, or towards the center point of this ball. And the fourth is coming from the reaction coming from the contact point C, that is RC. Now here we cannot apply the Lami's theorem, because Lami's theorem is restricted to only three forces. When three forces are acting at one common point, then only we can apply Lami's theorem. Here we cannot apply Lami's theorem. When the Lami's theorem is not applicable, then we go for the equilibrium of forces, that is equilibrium conditions. Now let us apply the conditions of equilibrium over here. Conditions of equilibrium. Here for the concurrent force system, we have two conditions of equilibrium. Those are sigma fx equal to 0 and sigma fy is equal to 0. Now what sigma fx is equal to 0 is indicating here? Algebraic sum of all the forces along x direction must be equal to 0. Now one by one we have to resolve all these forces along x direction, that is along x axis. This is imaginary x axis and imaginary y axis. Along these two directions we have to resolve the forces one by one. First we are resolving the forces along x directions. Now let us resolve. Let us take first 100, that is RB equal to 100. Its x component is 100 cos 30. Whenever the angle is known with respect to x axis, we use cos along the same axis. So after resolving, the component moves towards left direction, its sign is taken as negative. And the next reaction coming along x axis is from D point, that is RD, and its angle is with respect to same axis is 0, RD cos 0. And the third force component is minus RC cos 60. Last one, 200 cos of 90. 200 cos 90. Why we are taking 90? Because up to the x-axis its angle is 90. And when we know the angle with respect to same axis, we use cos of 90. Either you take plus or minus and equate it to 0. To maintain balance or to maintain equilibrium position in the structures, you have to equate it to 0. Now you cannot solve this equation because it consists of two unknowns. Keep the value of RD and RC as it is. RD cos 0 minus RC cos 60. This term becomes 0. Leave that and take this term on the right hand side, which become plus 100 cos 30. Let us give this as equation number 1, which consists of two unknowns, RD and RC. Now, in a similar way, you have to apply another condition of equilibrium, that is sigma Fy is equal to 0, which is indicating that algebraic sum of all vertical forces must be equal to 0 to maintain balance or to maintain equilibrium constant in the connected bodies. Now here, in this equation of equilibrium, we have to add all vertical forces in y directions. Now one by one, let us add the forces. Let us start from RV sine of 60. When you want to resolve that force along y direction, its angle is missing, right? When the angle is missing, we use sine. And after resolving, the component moves towards down. What is the value of RV we have? We know the value of RV, which is 100 sine of 30. And the next is 200 with an angle of 0 with respect to same axis. We use cos 0. And since it is moving like a downward force, take its sign as negative. And RD, here RD cannot be taken along y-axis because its angle is 90. Its component is plus or minus RD cos of 90. And the last one is the component of RC in y direction. While taking this RC in y direction, here also the angle is missing. When angle is missing, we use sine of 60. And after resolving, that component also moves towards up. For upward component, the sign is taken as plus. And now don't forget to equate it to here also 0 to maintain balance. Now in this RD term is already equal to 0. We will get the value of RC from this equation. Once we solve the value of RC, we will get nearly 288.67 in newtons. This is the reaction coming from the contact point C on O1 roller. Now once we put the value of RC, once we get the value of RC equal to 288.67 newtons, put the value of RC in equation number 1, we will get another unknown, that is reaction from the contact point B, that is RD. RD after solving, we will get 230.9 in newtons. This is how we can solve the unknown reaction from the contact point A, B, C and D using the equilibrium of forces concept, either by using Leibniz theorem or by applying conditions of equilibrium. Hope you like the videos. Please do share, give comment, and if you are not subscribed to my channel, please do subscribe to my channel. Thank you.